this second tutorial, I will show you how to create a structure for a two-dimensional problem. So in our first tutorial we'll look at a very simple one-dimensional system, silicon bulk. Here we will start to look at a two-dimensional problem, two-dimensional system. So I'll show you how to create a very simple two-dimensional mesh structure, and then how to use our input file for this structure. I will do it for a PN junction, so a diode, 2D dimensional diode PN. So let's start again from the geo file. Here I have the file, and in order to show you how does it work, I will do as in our first tutorial. I will just copy the line here and to show you the effect. Okay, here it's very simple because it's again as in the 1D. We just open this structure. Okay, so here we have 6 points. So point 2, point 3, point 1, 4. So again 1, 2, 3, 4, 5, sorry, it's on the left, 5 and 6. So we have 6 points which have been defined as in the 1D case. We have an array with 4 numbers. The first 3 are the coordinates x, y and z. The last one is the mesh parameter. In this case we have used 2 different parameters. So one from point 1 and point 4, which are the point at the center of our structure, and another parameters for the other 4 points, which are at the edges of the structure. Why? Because we want to have a better precision here in the middle of the structure, which will be the junction between the P and the N region. And we don't need this precision far away from the center, from the junction itself. So you know how I define the point. Now it's important to notice this. In this case we are discussing a two-dimensional structure, and by default we have to create this structure in the XY plane. As you can as you can see from here, we are in the XY plane. So it's important here, we just have to put 0 to the Z coordinate, and the system should be drawn in the XY plane. In this case we just put some number in for x, so point 1 is 0, 0 and 0, 1 and so on. So this is exactly as in 1D, but we are starting to create something in 2D in this plane here. Okay, now let's copy the second part. This also should not be too difficult, because we have the line. We already see how it works in the one-dimensional case. Okay, again, just reload. Okay, we have this line, this 6 line here. We just sorry, 7 line, because of course we have this in between, which is the junction itself, with line 6. So at this point nothing is different from the 1D, but now we have to consider the two-dimensional surface, because here we have 2 surfaces. And now I'll show you how to create a surface with the Gmesh program. Okay, first of all, you have to define a line loop. Okay, just copy this, just put here. We have this new instruction with line loop number 1. So it's 1, 2, 3, 4, 1, 2, 3, 4. So it starts for line 1 is for 1, 2, 2, 3, 3, 4, and then of course from 4 to 1. As I think you remember, in the first tutorial I told you that the line have a sign. So when you want to create a line loop, you have to be careful that you are going in the direction, in the loop direction of the same direction of the line, where they are positive in this case. So we can save. If we just look, we don't see any difference, but what we just created a loop here. So we start from line 1, line 2, line 3, line 4, and then, which is the second, okay, we can create a plane surface here. Plane, you have to be careful because we can also not plane surface. We will see it in another tutorial. So we define number 1 as the first line loop. Of course, you can put different numbers here, but if you have to remember that the second number here, it refers to the line loop you have already created, and then you have a plane surface. If we just save it again, go back to Gmesh, reload, of course apparently we have the same, but if we go again to visibility and we go to not to the physical group because we don't have it yet. Okay, here we have a surface, which is this one. You can see this surface is done by line 1, by this 4 line and this point here. Okay, so line 1, 2, 3 and 4, and point 1, 2, 3 and 4. You have created a surface in this way. Okay, now we want to create this is the top surface of the structure. Now we want to create this other. So the syntax is the same, but now I can show how it's important to remember that the lines have a sign, because if we want to create the other one, the second line loop, the second surface here, okay, you see we have 5, minus 4, 6, 7. Why? Okay, let's go back to here. Okay, so here we have line 5 from point 5 to point 1. Line 4, why it should be negative? Because line 4, so we are from point 5 to point 1. Now we want to go, we are going in this direction from 5 to 1. Now the loop have to be done in the same direction, so we have to go to point 4, to point 1, sorry, to point 4. But this is not as in line 4, because we have 4, 1, we need 1, 4. In order to go along the line in the right direction, we have to put a minus. So to tell the program we are going from point 1 to point 4. And then we have line 6 from 4 to 6, it's okay. Then we have from point 6 to point 5, it is correct. 6 to 5 is line 7. So here we have line 5 minus line 4, line 6, line 7, and then we create the second plane structure here. So reload, okay, go to the visibility. Now we have two surfaces, this top surface and the bottom surface, surface 2. Okay, this is the 2D structure. It's almost created, because what we need now is just to define the physical entity. So we have two physical surface, surface 1, which is an N-type in this case, and surface 2, which is the P-type of our NP junction. Again, in the R surface, we have in the first tutorial we have physical line from the region. For the region, if we have two physical surface, then we have what we will use for boundary condition, which is in this case are not point but they are line. So in this case the anode and the cathode are line. Here we can save, and here we can reload. Of course, again, it's the same structure, but here we don't only have the elementary entities, but if you look to physical group, okay, we have surface 1, the N-type, surface 2, the P-type, boundary condition, anode here at the top of the structure, and the cathode here at the bottom of the structure. Of course, here we have to, when we look at the file, the input file for the Gmesh, you have to be careful. The anode is line 2, which corresponds to the line we have here, the top, line 2 again, and the other, of course, is line 7, which is the one at the bottom. Okay, the structure is done. You can close this tab here and go to mesh. In this case, we have to go to the 2D. Just reload. 2D. Okay, here, very nice. You can also have a look at the mesh itself. Of the region of the mesh is a triangular mesh by default, and you can see the importance of the parameters that we put as a fourth number in our array here for the point. So this CL2, which is just for the point in the middle of the structure, and this CL1, which is at the edge. You can see how more precise is the mesh at the junction of the two regions, and how here is much more precise. You have with different density of the mesh points here. Very interesting, I guess. And then we can save this mesh. Okay, we have already one. If you already wrote a mesh file, you want to change it, you have to remember to replace every time to save it. And now here in our folder we have a file which is correspond to the mesh. Now in the second part of this tutorial I will show you how to use the input file for this PN junction.